Well, hello and welcome to Knock Knock. Who's there? Identifying assets in the cloud. My name is Ben Sadeghipou, and I also have Tanner Barnes here with me. We'll do a quick introduction in a little bit. For this talk today, on our agenda, again, we're gonna do an intro really quickly, talk about why we were so focused on the cloud, talk about our solution and what we designed, how we did some mass exploitation, and then talk about some real life bug bounty examples. I'm Ben Sadeghipou. I'm a hacker, husband, and a gamer. I'm the head of hacker education here at HackerOne, and I'm a content creator and streamer. So if you find these kinds of topics with hacking and bug bounties interesting, feel free to drop in on YouTube and on Twitch and watch me do more of this stuff live. And I'll let Tanner quickly introduce himself.
Awesome. Thanks, Ben. So yeah, as I said, my name is Tanner Barnes. I'm on Twitter and all the things as Static Flow. So I am a developer, a pen tester, and occasionally I do some bug hunting as well. My job currently is I'm at Aon Cyber Solutions as a pen testing consultant full-time. Some of the code I build for the hacker community, which is mainly my focus, is on GitHub at that link. And then I do occasionally do some live coding at Coding with Static Flow on Twitch. Cool. So part of this talk, right, kind of centers around our research in the cloud. So a natural question is, why scan the cloud? Well, it's still cheaper. There's still cheaper to do it yourself than options like Census or Shodan. Some of those licenses can be incredibly expensive. And additionally, who isn't in the cloud, right? Especially if you're looking at your large organizations, Verizon, AT&T, Yahoo is a part of Verizon. Just kind of all across bug bounty and the scene at large, pretty much any large organization is going to be in the cloud. So it's a very target-rich environment. If you're looking at AWS, Azure, GCP, Alibaba, DigitalOcean, if you're looking at just their compute space, so an equivalent would be like EC2 on AWS, you're looking at about 88 million different IP addresses, right? So a large attack surface that possibly has bad bug bounty targets in it. So it also allows us to see areas where currently some new resources are being deployed by large organizations. So we're seeing, from looking at our data, where we're seeing a lot of quickly spun up and then spun back down instances at these large organizations. So they're using the cloud for testing some maybe new features, and that in and of itself can be some very target-rich areas. Next slide. Right, so kind of looking at an idea of what's out there, right? So we took a kind of a stock of common subdomains or subdomain pieces to kind of get an idea of what might be out there, right? So 1,000 corp, subdomains, 13,000 internal subdomains, which we found very fascinating that something with the name internal would be out there on the public cloud. Dev, that's to be expected, especially like we said earlier, looking at a lot of testing environments that are being put out in the cloud. APIs, those are super common nowadays to have those spun up in the cloud. OAuth is an example of, or Oath is an example of something specific to Verizon, right? You're looking at almost 5,000 of those subdomains out there. And then Yahoo, the large and ever popular bug bounty domain, sitting at 108,000. It's a huge area, attack surface wise. Right, so now we'll get into a bit of our solution, how we were able to get at those 88 million IP addresses, right? So it's built in Go. Go routines are a huge win and a good way to really make something like this happen. That's kind of one of the hallmarks of Go, is that it is incredibly concurrent and can really help you knock out a lot of concurrent type of workloads really simply. At how it works kind of is a simple thing. It's really just a scraper for CNAME and DNS name records from TLS certificates, right? So not a lot of magic really in the code, but the issue becomes it's really simple to write a scanner that can pull those from a certificate, but the issue becomes now, how do we scale that to tackle 88 million IP addresses? So this is my favorite slide. I had a lot of fun writing it. When I sent it to Ben and some people, they were really taken aback, and it was just a lot of fun to build. So we ended up getting to a point where we were able to do 1.4 billion unique targets in 15 minutes, which ends up at a rate of about 1.6 million a second. So the way we're getting to that 1.4 billion is we take those 88 million IP addresses, combined with some other large CIDRs from bug bounty targets and some ASNs, combine those all up into about 535,000 /24 CIDRs, which a /24 has 256 IP addresses. And then we, across those /24 CIDRs, we looked at 11 unique ports. So that's what you end up with your 1.4 billion unique targets across those IP addresses across 11 ports. Once that scan's done, we found about 28 million identified targets on those 11 ports. And what's really amazing is that all of that costs about $25 in AWS charges. So just pennies in the bucket, drops in the bucket for what we're able to hit that fast. For every great side of a coin, there is kind of a flip side that's not so fun. We learned a lot of lessons that ended up with some maybe not so fun AWS bills along the way to that amazing $25 scan charge. We tried some really silly things with Lambda. You can do a lot of really concurrent, really fast things with Lambda. They will not let you spin up 535,000 of them, though. And that was found out immediately by a very large AWS bill. Because sadly, once you kick off Lambdas, there is no stopping them. So once you tell Lambda to run 535,000, it will do it. And there's really no stopping them. From a code standpoint, every bit of memory and CPU cycle really matters, especially when you're going through that much data. So at first, to get like a baseline, it was really just kind of rough and dirty. But then to get that type of 1.6 million, you really had to spend a lot of time with some profiling tools, really cutting out the fat from the software to make sure it's doing the bare minimum as fast as it possibly could. And kind of as a last lesson learned, you really got to be careful with who you're scanning. Once we had this raw data of the 28 million targets, we wanted to try to get some sense of what was out there on those targets. And we inadvertently ran into some people who weren't so happy with that. And we got some really hilarious LinkedIn messages from some CISOs and some people really not happy that we were poking around. So definitely things to keep in mind when building large scale tools like this. So more past what do we do, with all that data is, so we have all these targets, right? But we want to know something more about them than just that they exist, right? So we turn to looking at ways we can enrich the data to really do something with from a bug bounty standpoint. So the first thing we needed to do, right, was take those 28 million targets that came back and figure out which one of them are bounty targets, right? So we used a handful of resources. There's a really great GitHub repo that we'll get to a little bit later that had a large list of kind of pre-compiled bug bounty targets that we were able to use to sift, and then just kind of our own knowledge of what common bug bounty targets were. So that was kind of our first step, right, is getting just a bug bounty table of data that we can start looking at. Once we have that data, a really interesting type of next step to do that we got a lot of success with was diffing the scans, scan to scan, to see what was newly created, right? So if you have a scan on Monday and you're scanning again on, say, Thursday, what's really fascinating or what's new has changed from Monday to Thursday, because those are going to be your most recent and maybe most vulnerable targets, right? So the diffs that we would check every day really got us a lot of interesting results there. Another thing was checking for vhost discrepancies. So some of these targets responded differently based on the host header you gave them, right? So we built a tool that we'll demo, or not demo, we'll release later at the end of the talk, where you can take a host and it will check that host based on access by the domain, by the IP address, and by a host header of localhost, and it will check the response links and status codes to see what might be different there. So we were able to find some really, really interesting targets that we were only able to identify by checking those vhost discrepancies. Some of the last things, we were able to do things like pulling titles, response links, and status codes in general, just to kind of get a lay of the land of what was running on these targets. And that kind of lent itself easily to doing fingerprinting. So we built another tool that we'll be releasing as well, that you can supply it a customized fingerprinting list, and it will check whatever targets you give it to see if they match those fingerprints. Next slide. Right. So looking at extracting bug bounty targets, right? So again, 1.4 billion targets, a lot of noise. This was a repo we were mentioning earlier. It's bounty-targets-data. So that was a huge help in kind of getting a first start and a first crack at what is an interesting target to look at, right? And so we filter them at scan time. So as that scan is happening, we're kind of bifurcating the data and writing them to two different locations. So we aren't having to go through the data afterwards. We're just kind of doing it at the same time it's happening. And this kind of gives us our first set of targets to provide into further tooling, right? Next slide, please. Sure. So again, like we said, the diffing, obviously multiple scans, whether they're a week or a month across, are obviously going to have a lot of overlap, right? When you scan on Monday, if you come back and scan a month later, Tesla.com is going to be in there twice. That's just a given. Tesla is not turning their site off anytime soon, hopefully. So you kind of need a way to filter through that noise of what is an interesting new target, right? And again, like I said, it's most useful for finding those newest hosts from the most recent scan. Another fun thing that we were able to do with the diffing is it allows us to learn really well how targets are naming their hosts. I think it was a really fun message from Ben about a month into this, where he noticed that he had basically clocked that the way a certain bug bounty target had named all of their hosts. So we were actually able to tell ahead of time what hosts might be in existence just by looking at all these diff scan data over multiple days and weeks. We learned a lot about their organization. And then we're able to do a lot of fun things with just historically keeping data. So all the data from scans we've kept archived in cold storage. So if ever we wanted to go back and look at a kind of large sentiment analysis or just a large understanding of how an organization works over the months and days and maybe a year, we have all that data and we can go back and learn some really fun things from that. Next slide, please. Right, and so the next part being virtual host discrepancies, right? So after every scan, we take our targets that we're interested in. Normally we would run this against the diff results. Is we're looking for the status code and the response link for three specific cases, right? When we hit it by the IP with a host header of the IP address, when we hit it with the IP with a host of the domain that it comes back with, and then the IP address with a host name of localhost. And as an example here, you can see an AEM instance that we found on a bug bounty target that happened to be vulnerable to a couple different things that you can see very clearly here. By accessing it by an IP only, we get a response. But if we hit it by a host header of the domain, we get nothing, right? So that tells us that there's something there, right? They don't want you hitting this, or there's something blocking you from hitting it by a domain. But if you come at it by IP, it's happy to let you in. And so I'll let Ben take it away with some of the kind of mass exploitation and just exploitation as a whole that we did with some of these targets.
Yeah, thanks, Tanner. Again, so we're trying to do things at scale. And one of the things that we forgot to mention was we were originally going to test this thing out for a whole year. But unfortunately, we cut down our timeline from a year to 2 months. So we really had to move quickly because we wanted to get this in. We wanted to start doing these talks this year instead of waiting for next year. So we cut our timeline. We had to get creative. And mass exploitation was a very, very big part of it. So how does it look like? Well, you have two options. One, you can either go after a single target, you mass exploit the same mistakes over and over that you know they have made, or you go after multiple targets based on things that you have seen as a pattern across multiple organizations. If this doesn't make sense right now, I promise it will make sense by the end of this talk. But let's talk about the single target. So for a single target, you have to pretty much base it on what you already know. So if you know where the deployment process is like, how do they name the APIs, where do they store it, where are the docs stored, and what are the internal corporate sites. So if you not have that information, you do your basic recon, you gather this information, it makes it easier to deal with. So as an example, if you are familiar with the Verizon Media Bug Bounty and you've watched my streams online, you can tell that they're notoriously very well known for leaving API documentation behind. And they have this port 4443 that is very, very interesting. And a lot of times it has some really, really juicy APIs. So we knew all this data and we already knew all these things existed, but we just had to figure out a way to access them across every single yahoo.com or Verizon Media domain. And we'll talk about how we did that in a little bit. But then there's a second thing where you want to mass exploit multiple targets, what I call the spray and pray. So you realize that there are mistakes that are made regularly by developers or folks that are behind these assets, and you pretty much shift your focus to things like known vulnerabilities. You focus on things like Spring Boot, Jolokia. You look for API docs because you know everyone's going to use Swagger application waddle. Again, you look for sensitive and internal tools that were supposed to be internally hosted and accessible, where they're not accessible by the domain directly, but if you hit it with the IP address, it may give you access to that GitHub, GitLab, Jenkins, or Jira instance. So we keep all that in mind, but still, we have to figure out how to identify them. And proper identification is a huge, huge part of this entire thing. If you're not doing this properly, then you're going to be always a step behind, because at this point, you're dealing with a lot of false positives. So how does that work? Well, let's figure out what we want to work on first. What are you going after? Understand what that thing you're going after looks like. What makes it unique? If you're going after GraphQL, what makes GraphQL unique? How do you identify it? How do you fingerprint for it? And if you're looking for Swagger documentation, same thing, Grafana, Spring Boot, all of that stuff. Make yourself familiar with all of those different things that make these applications. So response headers, response body, a specific endpoint. This could be a fave icon. It could be a particular endpoint, an API endpoint, a login page, and so on. So let's talk about some examples. If you are looking for Swagger, Swagger has a Swagger resources endpoint that if you hit it, it will tell you where they are holding the documentation. And it also has a keyword in there. If you look, it says Swagger version, and it says the version for it. So in other words, if I hit Swagger and if I hit Swagger's resources and it has the word Swagger version in it, that tells me I have API docs for that particular website. Another example of it is if you just hit Swagger API docs, where the actual API documentation are, you want to look for the keyword base path, because they have to, by default, specify where the base path of the API is. And that's something that you can also go after and look for where you're searching for these things in mass. And of course, last but not least, GraphQL. If you ever hit GraphQL / GraphQL, and I want to say in almost every instance, I could be wrong, but in almost every instance that I have seen so far, it will return a 400 baud request, and it would also tell you that the get query is missing. So again, if you wanted to look for GraphQL, you would have to look for the get query missing in return and make sure that the response code is a 400 to avoid any false positives. And if you're looking for things like Grafana, GitLab, they're all the same way. If for Grafana's instance, if you hit /, it's going to send you to /login, and it's going to have the keyword Grafana in there. And also there is a Grafana logo as an SVG file that you can always hit and see if it's there to make sure this is an actual Grafana instance. But all that is cool. We know how to fingerprint for these things. We studied a little bit of what makes these things unique and what makes them identifiable, and we just wrote scripts that did it for us. So now that we have all this stuff, what's next? We have to use some tools to be able to exploit these. So we use tools like Meg. Meg is an absolutely powerful tool written in Go by Tom Nom Nom. If you're not familiar with Tom, go on github.com/Tom Nom Nom, sponsor his GitHub repo, and make sure you use Meg if you are doing things at scale and you don't have the ability to write your own tools like we did. And this is prior to what we were building. We decided to, while we build our own tooling and we have our fingerprints, let's work with tools that are already out there and figure out how we can do this as we go. So the way Meg works, it allows you to spray a number of endpoints against a number of hosts. And what it does, it saves a response code in a file called index within a folder called out. So if you go cat out index, this is what the output looks like. It tells you where it's stored and what the response came back. It came out at 302, 200, whatever. But also what it does is it also saves the entire full HTTP response in another folder within out. So it's out/subdomain or the IP address, and it has the entire response. So you can actually read that afterwards to make sure it's not a false positive. So if you can look, when I went after Netflix with all those IP addresses, every single request that I've made against those IPs are saved within its own file in that folder and out. So what do? Well, we get creative. I love Bash, and I'm pretty sure this is not the best solution to look for it, but we made a Bash one-liner that would look for things and tell us if it's there, and I'll explain what it does. But again, there's probably a better way to do this, but let's break it down and talk about what this one-liner does. So the first thing that it does is it grabs for the response code. So I tell it, hey, I want you to look for this particular response code, make sure it came out as 200, 400, whatever I'm looking for. And then I want you to tell me if, I want you to tell me if the output of the last command, and can I restart that again? Give me one sec. Okay, got it. So what it does is it grabs for the response code. So if I wanted to look for something that's returned as 200, it's going to tell me that. And then the next one is going to cut it out and just print out the location of the file. So if it came back as 200, tell me the location where you saved the output of this thing. And we're going to make sure it's unique. And then we're going to feed it back to an XRs and tell it to, hey, I want you to grep through all those files and look for this particular fingerprint. Tell me if the keyword that I'm looking for came back in the response that Meg saved within the out folder. And then I want you to cut it up again and just send me the IP address where this was found. And I made this whole thing, the one liner that I showed, I put that into a bin/search. So every time I type in search, I give it the 2 arguments, and it spits out every IP address that matched that fingerprint with that specific status code. And I will give some examples of that here in a sec. So now we're going to talk about how we use that to eliminate false positives. So first I say, Meg, I want you to concurrently run it in 70 times and look for Swagger resources within all the hosts that I have in host.txt. And we already know from previous slides that we're looking for the keyword Swagger version, and we want to make sure it comes back as 200. And if you can see, I know it's blocked off, but all the things that are under that white box are IP addresses that came back with the keyword Swagger version and /Swagger resources. Same thing if you do it with GraphQL. I said search for a 400 status code and the keyword missing, cut it up, and just give me the IP addresses. And every single one of those had GraphQL on them, and we did some really fun stuff with it that gave us leads or potential vulnerabilities. But all that is fun, but it doesn't scale with the automation that me and Tanner were working on, especially going after billions of targets and hundreds of thousands of IP addresses through the bug bounty cycles. So I'll let Tanner quickly explain how we did this with Go Fingerprint and why we did it.
Awesome. Thanks, Ben. So, right. So you're saying we needed something that did much the same thing, but that was kind of hands off for us that we could just feed in our scan data to. So that's kind of where Go Fingerprint came from. Very similar to a lot of other fingerprinting tools. There's really only so many ways to make a tool like that. Basically what it does is you give it a JSON list of a specific fingerprint or fingerprints, multiple if you'd like, and the type of just a name for it that you can identify when it comes back in results. So basically what it does is as our scan is complete, we have a setup where as the scan data comes in, it's fed into Go Fingerprint, which then uses a really great Go library called Colly, C-O-L-L-Y, which is a Go native built HTML crawler. So it will take a URL, crawl the data, and then you can build all of these iterators on those results to pick out different things you want out of the HTML data. So that's basically what it does, is it takes our list of targets, walks down the HTML looking for the fingerprints that we have, and then sends that back to us in a couple different ways. It writes it to a file, and we also have some kind of custom Discord hooks for letting us know a little bit easier that way.
Now, time for the fun stuff, real life examples, and I have a few of them, and some of them are very, very easy to catch because of the data we had, and some of them were strictly based on the fingerprints that we did. So the first one is asset monitoring. Like Tanner said, we figured out this company was naming things a particular way, and they were deploying things a particular way, which by default would give us a vulnerability if we caught it in time. So what did it look like? Well, about a year ago, just a big shout out to Space Raccoon. If you're watching this, Eugene, this one's for you. We found this XSS. It was on this site.com, dev, site.com, demo app HTML, and some parameter had XSS. Reported a year ago, never thought of it again. But naturally, as a habit, I took that endpoint of demo app HTML, and threw it in my word list just in case it comes up ever again. Well, it did come up. At some point, it came up when I was just hacking on random stuff on the site, and I realized that it's coming up more often than I expected it. So with Tanner, we decided to feed this thing into our tool and say, hey, look for this demo app, see if the fingerprint, and the fingerprint we have was a particular JavaScript file. Then the way the JavaScript file was named, it would come up every time in the HTML. We looked for it, and every time we saw a new asset go up on this company, we would run it against this endpoint, get an XSS, report it. And I think we caught about 6 times, at least the last time that we looked into it. We found it 6 times, and those were easy bugs to report just by having the data that's already in front of us. Hunting for CVEs is another really cool thing to do with being in the cloud, because a lot of times that's where they deploy them. They think it's not accessible because the domain doesn't work, but you can hit it with IP again. I'm not going to talk about the technical information on how the CVE with Grafana works. This is an unauthenticated SSRF in Grafana. If you want to watch this talk, you're more than welcome to look it up. Ryan Rader, Justin Gardner did a talk for how he found this exploit at HacktivityCon with HackerOne. Highly recommend watching it if you want to know how it works. I'm not going to cover that at all on these slides. But again, the way we did it, we knew the fingerprint. It's a 3022 login, and it's going to have the keyword Grafana in that instance. And the funny thing was, we also caught on halfway through that people love to just deploy Grafana on port 3000. That was a default port for it. If it's not on 80, it's on 3000 in a lot of cases. So we ran that fingerprint across all these ports and found a lot of targets that were on port 3000 throughout our bounty table and had the keyword Grafana in them, or we had login with Meg or through what Tanner had written, and we made sure these were Grafana instances. So once we had this, the exploitation, this is where it gets fun. So we pulled everything in 3000 that was in our bounty table. These were the bounty targets that we were monitoring. We pulled out everything that could have been Grafana. We ran it through Meg. We said, hey, look for everything that comes out as 200. Make sure it has a keyword Grafana. Give us all the possible instances. And we even got a little bit more creative. We skipped the login portion of it, and we straight up gave it a POC and said, hey, this is on AWS. Hit the IP address for the AWS metadata, hit latest, and tell me if you hit this particular POC and if you actually have an SSRF and the keyword metadata comes up, let me know, because if that does come up, that's a vulnerable instance, because we're abusing an SSRF to hit an internal IP address that's deployed on AWS by default. And if you hit /latest, metadata is a part of that. It's a folder within latest. So if it came back with all these different IP addresses, it would tell us, hey, you have found a vulnerability already. We don't have to verify anything else. And that led on to getting some really cool bounties. Again, I kind of went over this already a little bit fast, but when we designed the Go Fingerprint tool, we no longer really had to run it through Meg. We just monitored for assets that were tagged as Grafana, because the tool that Tanner had ran already was already looking for these fingerprints. So this one was one of the funnest ones. This is a huge mega Uber corporation. It's not Uber, I'm just saying it's a mega big corporation. And they were very surprised that we found so many instances of it. And this is because, again, we caught onto the port 3000. We went after every single asset of theirs that was running something on port 3000. And I want to say roughly about 12 or 11 different instances of this were vulnerable for a single company. And that just kept on giving and giving. So that gave us a ton of good bounties just by going after this particular CVE. These are all, again, the same CVEs on SSRF with Grafana instances that are publicly accessible. There are some there are some takeaways that you have to also understand. When you're hunting for CVEs, you don't want to report them too early. Make sure you give the company enough time to patch these things, because they're going to say it's a duplicate because they already knew about it. You know, you haven't given them enough time. It's an O day. Just be nice, play nice. If you don't get paid, walk away. You probably did it too early. And then the biggest thing is, just because a company has multiple instances of a vulnerable app doesn't mean they're going to give you multiple bounties. But I want to say 9 out of 10 cases, we ended up getting a higher reward or bonus because we went the extra step of identifying additional vulnerable instances. We also went after more stuff than just that. We at some point sprayed /admin across all of our targets just to see if anything comes back that says there is a login on this page. You know, it's redirecting to login, it's showing the word login, it's asking for a username and password. None of them really looked interesting, except this one instance where it was redirecting us to this MGMT some path login JSP. And the MGMT to me sounded like management, maybe, who knows? But when we hit it, it turned out that there is a admin side and the credentials were actually admin, and that got us logged in. But again, that is not a lot of fun because it's not that cool. You found an admin login, they messed up and they had the admin as their password. But we wanted to get a step further. We knew there's impact here already, but we wanted to also see if this mistake was made multiple times across this entire organization and see if we can find more of them. So let's talk about this. The URL for the site looks like WXYZ, which is the app name that we redacted. The permutation could be a different platform if they were playing on iOS, Android, whatever else. And then I wish I could disclose this target is the website that we were going after. That always stayed the same. And the slash thing is after you would log in, it would send you to that end. It would send you to that slash whatever app. And this was the core app, wasn't just named core app. It had a very unique name. So it would show that. So that was what we used for a fingerprint. So what we ended up doing is we went back to our target. We went back to our database and we looked for that app name, the XYZ, whatever it was. And we said, give us everything under this domain that we're going after that has an XYZ app name within it. And we fed it to Meg and we were able to identify 15 hosts that had the same exact login page as this one. And at approximately, I want to say 12 of them, as from what I remember, allowed us to use the admin credentials to log in. And they each had access to user data, PIIs, and from what the security team told us at this company, it was that there was about 1 million users' data on there. And based on the screenshot that I showed earlier, there were some server updating things we could have done. So probably had RCE by design. We didn't push it just because we already felt that we've pushed our luck a little bit too much by already logging into an admin panel in a production environment with 1 million users' data being on the line. So we reported immediately, and that got us a bounty as well. Now, this is probably one of the most fun vulns that I've worked on. This one allowed us to get some really, really cool data in this mega corp that we unfortunately can't disclose, but gave us access to some really, really cool internal assets. So based on the Spring Boot's documentation, we know that there are different endpoints that do different things. 2 of them in particular are very, very important. One is the HTTP trace, and the second one is the heap dump. The first one gives you the exchange, the response exchange. So if you make a request, if there is something on there, your cookies, your headers, all of that is being stored in HTTP trace. And the heap dump is obviously a heap dump of the application's JVM. But on top of that, if you look at the documentation, if you ever hit any of these endpoints, the content type will always have boot actuator inside of the header. So for the content type, we knew it's going to say Spring Boot actuator, and that's how we could identify it if there was a HTTP trace or heap dump available. Well, working with Tanner, ZLZ, and Zayed really wanted to own this mega corporation. So we went and dumped every single asset we could. We realized that you use this thing multiple times. So we just dumped every single asset and we sprayed HTTP trace against all their domains. And we came across this HTTP trace endpoint on a app, we call it again XYZ, but the permutations were XYZ internal prod site.com with an actuator HTTP trace. Interesting. It's internal and prod. Cool. That gave us some cookies, and naturally you take those cookies and you swap them out and you try to log onto the application that's on there. But unfortunately, I think that session was expired. Something happened. We couldn't log in. But that's interesting because it tells us there's internal prod, right? So we are looking at internal prod of this app, this version of this app. So that means there's probably a dev, a non-internal, just prod. Who knows? Like there's obviously there's other permutations of this. So what do you do at this case? Well, you try to play with these other permutations. We went back to our database. We plugged in the keyword for the app, so XYZ, and we said, hey, give us every single site that has the XYZ app name within this site.com. And it gave us 4 different permutations, one just being the app name.site.com, the next one being the app-internal, and then third one being the app-prod, and last but not least, the original one that we found that had XYZ internal prod within its name. But none of these were giving us any good data, but we knew that actuator HTTP trace was available on all of them. And once we started digging through all of them, we dumped all the data that we had from it, and we realized people were making requests to other folders outside of the actuator where we were in. So they were hitting things like core-corp, /application, /viewer, and again, XYZ services. So the app name services was a folder they were hitting that also had some stuff in it. And it turns out that all of those had their own instance of the HTTP trace that leaked more cookies and more endpoints and more information that we could have used. So naturally, again, you dump every single heap dump and every single HTTP trace that you can. We hit every single one of them and we gripped for cookies. And we tried every single cookie we could get our hands on until one of them hit and gave us a login to that application. So to take a step further, we realized since this is an internal app, they're probably using some single sign-on to make sure this cookie carries over and it lets you log into other applications that are owned by this company. So we made a match and replace through Burp Suite, and we told that every time we hit any of these megacorp sites, replace our cookie value with this cookie that we just found, and let's see if it works. And it did work. So we had some really cool internal sites that this one had access to about 4,000 people, all internal employees, probably email addresses, and you can see on the right side, we could have edited, deleted, whatever we wanted to do. This one was some sales thing that I don't understand what it was, but it was definitely internal and it was related to sales. This one allowed us to manipulate, I think, some user data stuff. We didn't want to mess with all this stuff because, again, these are production sites, internal, and it's a huge corporation. But again, just finding that one cookie that works because you leaked the HTTP trace gave us access to a lot of good stuff. But there's a lot of lesson learned with this. It wasn't easy. Again, this was an entire Sunday spent for us between the 4 or 5 of us to figure this out. So what we learned was dig very deep, find as many as these as you can, look for cookies. Don't stop for just cookies. Look for credentials, look for keys, look for authorization headers. It's not always cookies. They could have an API key in a request in a parameter. They could have a header that has an API key. They could have bearer tokens. All of that stuff matters. Stop brute forcing is a huge one because the more brute force you do, the more requests you do, the more you're flooding the HTTP traces logs, and you're not going to be able to monitor for actual valid cookies. And the best part of it all is, again, this megacorp, as we refer to them, wasn't the only vulnerable company. We ended up actually selecting a number of, I want to say 9 or 10 targets that we identified that were using the same exact thing. And we ended up spraying it with the same exact thing. And we ended up just getting more and more bounties as we were identifying them. I'll let Tanner wrap this up by some of the tools that we wrote to make this easier. And I think this might also help a lot of hackers or internal security engineers to identify assets that shouldn't be out there in the wild and in the open.
Awesome. Yeah, thanks, Ben. That was a really fun week. We had a lot of good fun there. Can you go to the next slide? Awesome. So these are the tools that we talked about previously that are out there for people to use. So the first is, again, Go Fingerprint. So it takes a list of URLs and a fingerprints.json file, which has those, different fingerprints that you built to look for different things, right? And so you can see in the top right there is kind of the output you'll get. You'll get the domain that it matched on, the URL that it matched on. And then after the colon, you'll get which, sorry, I'm going to start that sentence over. You'll get the URL, and then after the colon, you'll get whatever fingerprint that it matched. Okay, I'm going to start over again because my dog just stepped on a squeaky toy.
Yeah, I'm going to go to it again.
Let's just start the whole slide over.
All right, ready?
Yeah. So these are the tools we talked about earlier. Our first one is Go Fingerprint. So it takes a list of URLs, and the fingerprints.json, which we talked about, is where you'll put the custom written fingerprints that you have. In the repo, we have kind of a basic one that we were using for some testing, but you're welcome to write your own. In the top right, you can see there the output. You'll get the URL that matched, and then after the colon, you'll get which fingerprint that it matched for that URL. The second one is vhost scan. Like we said, it takes a CSV file, or really any file, of the form host name, IP, and port, and it returns a JSON file containing objects that have the input target and then the result for all three of the checks. Might be a little bit hard to see on the slide. Hopefully it's easy to see, but in that JSON document, you have the target you're after, and then it has the host name, it has the status code, and then the response length for both the three checks of IP with the host header of IP, the IP with the host name of the domain, and then a host name of localhost. Right, so this is a fun slide as well for something we decided to do. This is actually a little bit outdated. The current, let me just stop. How do we want to, because we'll go back and do this. How do we want to actually do this slide, since it is kind of...
I would just say there's an API out there that you can hit, and it will let you get some of the data for free. And if you want to get more data, we have a pay as you go right now. You can get access to our data as you pay.
Sure. Okay. And
because everything is there. The API is still, they just have to register on recon.dev.
No, that API.recon.dev. Well, I guess it is there. Yeah, but it's not gonna. Yeah, I'll just say that if you go there now, it's gonna take you to. It's gonna redirect you to our site.
And you can use the site to get this data if you want.
All right. So along with the tools that we released also an API to give you access to this data that we've been compiling. So you can go there at api.recon.dev. Currently, you'll notice that when you get there, it's going to tell you that you're missing an API key. That's because we've most recently moved this to recon.dev. And you'll have to sign up for an account to get access to the data. So it's fairly simple. We have 3 different kind of pricing tiers. There's a free one, so you don't have to worry about, we're not trying to price anybody out of this data. So there is a free way to access the data. You can hit it one domain at a time, and there's no need to do any type of like periods or any subdomains. You can just simply put in the root domain you're after, and it's going to return a JSON document with all the results for that domain, with both the CNAMEs and DNS names that match that domain, the port that it was found on, the root, the like IP address that it would match to, and the root domain that it matched to. So I'll let Ben kind of wrap it up for us.
So conclusion, some of the things that we did learn is understand your target, understand where to deploy new apps, understand how they deploy them, get familiar with all these different tools and things that companies use to deploy their apps. Get good at fingerprinting. Understand what makes these apps what they are. How do they behave to certain things? What do they return? What are the headers like? Just get to understand them. And also create a really good database of your own. You don't have to do this like we did. You can obviously use our data, but if you have a good way of keeping data on your own and having a database, it really, really helps to hack on these companies and get an overview of what their assets look like, what is new, what's old, and what's internal and whatnot. And just a quick reminder that a lot of the things that I showed as examples for vulnerabilities, just an example of all the examples that I've shown are vulnerabilities that were old tricks. There was nothing new, but it just shows that there are still a lot of low-hanging fruit out there. You just have to understand how to approach them and how to look for them. And some of the stuff that I showed, like example with the heap dump, that is a really good way for a person with bad intent or a black hat hacker or whatever you want to call them to get into a internal environment for a company and start pivoting through and getting access to more stuff or starting their own campaign. Don't just spray and go after assets with generic word list. Really go wide, understand how the entire organization looks like, and then look for common things that gets missed because you need to have a login, you need to have a cookie attached to your request, and really dig deep. You have to go a step further than just, again, brute forcing with generic word lists. Log in and then do brute forcing. Create word lists that are particularly made for your targets based on previous information and experiences you have had with this. If you don't have that, that's okay. You can build that as you go, but always take some good notes of juicy information and endpoints you come across while you're doing a recon. And hate on this last sentence all you want, but a lot of people say that bug bounties aren't worth it to make money. There was roughly about 50K in bugs in this presentation. We just spent the extra time to learn about our targets, to know how to exploit them, and we went after impactful bugs. Again, the things that we showed, you can access a lot of this data through census, through Shodan, through cert.sh. You just have to know how to use them properly. You just have to learn how to manage your data better and seriously spend your time understanding these targets before you decide to attack them and go after them. I have this last slide in there for no reason. I just love this meme that was given to us. And look into some of these talks. Orange Side did a talk on path normalization at DEF CON. I would definitely give that a look. You can see a lot of CVEs that have came in the past year are all caused by it. And this was a really big part of us understanding a lot of our targets. I wanted to give an example of this, but unfortunately, because our time was really, really limited, we don't have an example, but look into it. I promise it's worth it. It's a tip for people that want to go beyond just spraying with a word list. Again, thank you all for watching, and a big, big thank you to Zayat, ZLZ, Donut, Tom Nom Nom, Irby Sam, and Ryan Raider. And we appreciate you all being here. Cheers.